Okay, we are going to be learning how to graph with vertical stretches and shrinks. The important thing to remember when you have a vertical stretch or shrink, the factor is outside. Outside in front of the function. Outside in front of the function. If you notice here, there's a 3 out in front, not getting squared. That's in front. That's a vertical stretch. Here's the 1/2. That's in front. So the first thing we're going to do, okay, we're going to graph our basic in black. So hopefully everybody remembers the growth pattern. The basic growth pattern for a parabola is over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7. So let's go ahead and graph that. This is just review from yesterday. Over 1 up 1, over 1 up 3, over 1 up 5. Okay, if at any point this is going too fast, please pause the video, do your drawing, and then hit play or rewind if you want to hear something again. Okay, this next example has a 3 out in front. So that's the new thing for today. That 3 out in front means vertical. Is that going to be a stretch or a shrink? That's going to be a stretch by 3. I really wish you could see me right now because I'm pulling on the top of my head and I'm vertically getting so tall and skinny. It's really cool. Which of these numbers here are the up numbers? The vertical ones are the 1, 3, 5, 7. And we got to stretch them by 3. So we're going to multiply them all by 3. We're going to go up 3, and then 9, and then 15, and 21. Okay, so let's start at the origin. We're going to go over 1, but this time up 1, 2, 3. Then we're going to go over 1 up, I don't think I can fit 9. 9 is going to be a couple boxes off the graph paper way up here. So I'm going to put a point there just so I have something to aim for, which means I'm not going to hit the next line on this graph paper till I'm off the paper. So you're not allowed to touch the next one since you'll be off. Does it look like this parabola got taller, that your basic one is tall and skinny? A vertical stretch makes you tall and skinny. Okay, this next example right here has a 1/2. Is the 1/2 getting squared? Certainly not. That means that it's outside. That's a vertical shrink. Vertical shrink by 1/2. So that means all my vertical numbers, the original 1, 3, 5, 7, needs to get cut in half. So not 1, but a 1/2, 3 halves, 5 halves, 7 halves. Okay, so we got to do some fraction work here. First I go over 1, then I go up a 1/2. Now I got to go 3 halves, which is 1 1/2. Okay, so if I go over 1, I got to go up 1 1/2. That means half of a box completes it, and then up 1. So you should be at the point 2, 2, negative 2, 2. Okay, 5 halves is 2 1/2. So you go over 1, up 2 1/2. Now you're at the middle of a box again. 2 1/2 takes you to a middle. Oh, 7 halves is 3 1/2. Oh, that's nice because the half completes the box and you got to go 1, 2, 3. You should be at the point 4, 8 at this point. And negative 4, 8. Okay, I think that's all I can fit. Here is my vertically shrunk parabola. If you are vertically shrunk, you should get short and fat. If you stand up and you make yourself half as tall and squish you down, you'd be short and fat. Okay, and the last one. Oh, I see a bunch of transformations. Okay, step 1. The negative out in front means reflect over which axis? The x-axis. Step 2, the next thing I see is a 2. Is that 2 getting squared? No, it's out in front. That 2 means vertical stretch by 2. And then the final transformation is 1. That plus 1 outside, up 1 unit. Okay, so let's see. What is this going to look like? The first step is reflect over x-axis. The parabola is going to be opening downward. Vertically stretch, I'll do that when I get there. I'll vertically stretch him. And we're going to start 1 unit up. Okay, so up 1 unit. There's your starting point. Now vertically stretching by 2, all of your up numbers need to get multiplied by 2. That's going to be 2, 6, 10, and 14. Okay, so this parabola needs to go down. So I'm going to go over 1, down 2. Okay, now we go over 1 and down 6. There we are, over 1, down 6. I don't believe I can fit 10, so I'm just going to get off the graph paper like this. This should be the skinniest one on your graph paper. Reflected over x-axis, vertically stretched by 2. Okay? Alright, let's go take a look at x cubed. First thing we'll do is review our basic. The x cubed growth pattern from yesterday, I hope you studied. Over and up goes over 1, up 1, over 1, up 7, and then over 1, up 19. Okay, let's do this. This is a cubic. On the origin, over 1, up and down 1, over 1, up and down 7. There we go, basic cubic. Okay, don't make him like a flat line. He's got a little bit of curve to him. Okay, let's do some transformations now. This first graph, I see a 2 out in front. That means vertical stretch by 2. Alright, the vertical numbers are the up numbers. We're going to multiply them all by 2 to get 2, 14, and 38. I don't think that's going to fit, but good to know. So we'll start on the origin, over 1, up 2, over 1, up 14 is clearly not going to fit. This cubic is going to be super duper skinny. If you take the basic one and you pull on his arms and vertically stretch him, he's going to get skinnier and skinnier and lose a lot of his curve. Vertically stretch him. Vertically pull that graph. Okay. The third one here, I see 2 transformations. What does that 1/4 mean? It's out in front, so it's a vertical shrink by 1/4. Okay, so let's take our original vertical numbers. 1 would become 1/4. 7 would be 7/4. And 19/4. Let's see, 7/4 is 1 3/4. And 19/4 would be 4 3/4. That would be good to know so we can do our fractions a little easier. Okay, oh, and there's also a 6 inside getting cubed. That 6 wants me to go 6 which way? To the right. 6 to the right. Okay, let's start 6 to the right over here. There's our starting point. We got our growth pattern. Are you ready to go? Over 1, up a 4th. Okay, as long as you're in the middle of the box somewhere. My 4th looks pretty close to my 1/2 or my 1/3. That's okay. Now we're going to go over 1, up 1 3/4. Well, 3/4 finishes the box, and then another 1. I'm at the point 8, 2, and over here, left 1, down a 3/4 and 1, I'm at the point 4, -2. Okay, let's keep going. Now we're going to go over 1, up 1, 2, 3, 4, and 3/4. Over 1, down 1, 2, 3, 4, and 3/4. There we go. Wow, look at the curves on this one. This cubic got a lot curvier. But if I vertically shrink you, you're going to get short and curvy. Short and curvy. Okay, the final cubic. There is a 2 out in front. 2 out in front. That means vertical stretch by 2. Vertical stretch by 2. So the numbers are going to be 2, 14, 38. Step 2, I see a 5. Which direction is that going to be shifting? Yep, 5 to the left. And step 3, I see a +3 outside the cubic. Outside means you go up 3. Okay, I've got the vertical stretching happening right here. We have to start 5 to the left and 1, 2, 3 up. And other than that, it's going to be facing the same way. Okay, a cubic that is stretched. Here we go. Over 1, up and down, 2. Over 1, up and down, 14. 14 is definitely not going to fit this way. Does 14 fit that way? 11, 12, 13, 14. It's going to be 3 off the graph paper down here. So I'm just going to aim for the point way off the graph paper like that. Okay? Basic cubic with some vertical stretching and shrinking. Alright, the third type of graph that we have is a absolute value graph. Did you guys study him last night? I hope you did. The absolute value graph has a growth pattern. He goes over 1, up 1. And then he goes over 1, up 1. Over 1, up 1. Over 1, up 1. That's going to be nice. Okay, so let's graph our basic. Make sure you put as many points as you can all the way to the edge of a graph paper. Don't be a lazy butt. This is easy. Too easy? I could get harder ones. No. Let's do easy ones. Okay. Make sure we use a ruler and put some arrows. Our basic absolute value graph. Okay. This next example here has a 5 out in front. It's out in front of the absolute value, so that means a translation that is vertical stretch. Okay, vertical stretch by 5. Which ones of these are the verticals? The ups. And this is where I really like absolute value, because 1, 1, 1, 1 is simply 5, 5, 5, 5. Okay, let's do it. There's no other transformations, no shifting, no reflecting. Over 1, up 5. Over 1, up 5. That's it. This is a really skinny absolute value graph. But remember, if I vertically stretch him up, he's going to get really tall and skinny. Okay. Next graph. I see a 1/2 out in front. That means vertical shrink by 1/2. And that 5 wants us to go which way? 5 to the right. Oh, that's weird. I know, you see a minus, but he goes to the right. Okay, so vertical shrink in 1/2. Your up numbers, multiply them all by 1/2. 1/2, 1/2, 1/2. Let's go 5 to the right. Starting right there. Over 1, up 1/2. Oh, I always kind of mess up the 1/2. I'm not really good with halves. Maybe what I'll do instead is go over 2, up 1, and these points right here on the edge of the corner of the box, those are the ones I'm really going to look for. So maybe to speed things up, I'll go over 2, up 1. Over 2, up 1. Over 2, up 1. Over 2, up 1. This is the only graph, the only type of equation you could skip like that. Because he's linear, he's going to constantly do that same thing. You can't skip with parabolas, and you can't skip with cubics because they don't have the growth pattern 1, 1, 1, 1. But you can skip and speed things up with absolute values. Okay? This one does look vertically shrunk. He looks shorter and fatter. And the last one. Is this equation ready? Everything ready? Is the x alone? X plus 3? Yeah, that's good. 1, 2, 3. There's 4 transformations. From left to right, you must do them in order. This first transformation means reflect over which axis? That's going to be a reflect over the x-axis. Step 2, I see a 3. That's going to be vertical. Is that stretch or shrink? Yep, that's a stretch. Vertical stretch by 3. Step 3, we're going to go 3 units to the left. And finally, we're going to go 3 units down. Okay, let's get our vertical stretching over here. Vertical stretch by 3, the numbers are 3, 3, 3. Reflecting an absolute value graph over the x-axis means he's going to be pointing downward. Okay, so we got to open him down. The stretching we've taken care of here. Oh, we have to go 3 left and 3 down. Okay, so here's our starting point, and this V is opening down. All right, let's do it. Over 1, down 3. Over 1, down 3. All right, there he is. Over 1, down 3. Yesterday, in the notes, I explained how you could quickly check to make sure you're getting problems right. You can take a point and plug it into the equation, but don't take the vertex, because if it was supposed to be opening up, that wouldn't tell you any mistakes. I'm going to take this point right here, -2, -5. And I'm going to see if my graph ended up in the right place. So let's take -2. -2 plus 3 is a 1. Absolute value of a 1 is a 1 times -3 is -3 minus 3 is -6. Uh-oh. Wait a minute. 1, 2, 3, 4, 5. Oh, that is a 6. Okay, good. Everything is working out. You can take a point and plug it in to catch your mistakes. This entire chapter is going to be without a calculator, so please practice some algebraic ways of checking your graphs. This is the only thing I can possibly grade. Please make sure you have points and arrows. Okay, the last graph is the square root function. Square root function has a growth chart. He goes over 1 up 1, over 3 up 1, over 5 up 1, over 7 up 1. Remember, he's got the same growth as the parabola, but he grows over instead of up. What some people tell me they do is they just turn their paper this way and they draw the parabola. 1, 3, 5, and then they put their paper back because it's easier for them to draw a parabola. That's a good technique if you like to do that too. Okay, this next example here has a 2 out in front. That is going to be vertical stretch by 2. Now which of these numbers is vertical? Oh, the ups. Oh, this is actually going to be easier than I thought. All the ups are 1s. Multiply them all by a 2. Okay, let's get started. There's no other shifting or reflecting, so we'll start the origin. Over 1, up 2. Then go over 3, up 2. Then go over 5 and up 2. All of the points are directly above the other ones, but they're twice as tall. This graph got vertically stretched. It should be the same graph but taller. Very nice. Next example, I see a 1/2 out in front. Out in front means vertical. Is that a stretch or a shrink? That's a shrink. That's a shrink in half. So cross those out. All of your 1s, all of your ups are going to be a half. Okay, so we go over 1 up a half, over 3 up a half. That brings me to a full box. Over 5 up a half. Look at that. All of these are directly underneath my basic, but my basic one's up here, and this one's half as tall. Half as tall, vertically shrunk. Okay. And it's time for the last one right here. This last equation. Oh, this one's not ready. Red star. It is not ready. What we have to do is rearrange the inside. Rearrange the inside is going to make this, let's see, the square root of negative x plus 2. Okay, but that's still not ready. Remember, you have to get the x, the plus minus quantity alone. We have to factor that negative away from him. Not out of the radical. Keep it in the radical, but we have to use parentheses and say x minus 2. Okay, that looks good. I see lots of transformations here, and we're going to go left to right in order. This first negative wants us to reflect over the x-axis. This 3, that means vertical stretch by 3. What does the negative inside want us to do? That's a reflection over which axis? That's the y-axis. And finally, that minus 2 means that we have to shift 2 units to the right. Okay, vertical stretch by 3. These are all going to become 3's. And now let's think about this reflecting. If a basic square root looks like this, and I reflect him over the x-axis, that's going to put him down here. But then I also have to reflect him over the y-axis. So this graph will now be going this way. Okay, this is the way he's going to be growing. Down, down, left. Down, down, left. That is the direction of the graph. Our vertical stretch we've got right there. Let's go 2 to the right, and we'll get started. Okay, we're going to go down, down to the left. We're going to go down 3, over 1. Down 3, left 3. Down 3, left 5. Alright, down, down to the left. This one was really complicated, so I definitely want to check. Don't take this point, because everyone knew to go 2 to the right. But did things end up correctly? I'll take the point here, 1, negative 3. Let's put a 1 in. 2 minus 1 is 1. Square root of 1, 1 times negative 3. Oh good, it worked. Make sure you take the time to go ahead and check. I want to see all these notes very clear. Tomorrow in class, you're going to work with your groups, and you're going to practice graphing with some vertical stretches and shrinks. Good luck, students. See you soon.